This is another variable geometry spring problem. This is actually from one of the Hibbeler editions, and where you have two springs and a force that's applied horizontally to those two springs. Both springs are identical, and so you have a spring constant that's 500 Newton per meter. For both of these, they have an unstretched length of 3. And we're going to pull on this guy with a 175 Newton force. And the question is, at what point does this reach equilibrium? This is your free body diagram. And so we're drawing the free body diagram of this point right here. I have an Fs at a theta, Fs at a theta, 175. I can write my equilibrium equations. In the x direction, I have 175 minus, this way I took to the left to be positive, so I have 175 minus 2 Fs sine theta is equal to 0. In the vertical direction, I have Fs cosine theta minus SF Fs cosine theta. And so I just get Fs is equal to Fs, which is we knew because they're the same spring. So that gives me one equation, but I've got two unknowns. I've got Fs and theta. So I need another equation somewhere. If you set up this right triangle here, where I've got L, and this is 3, and this is theta, then I have L cosine theta is equal to 3, or L is equal to 3 over cosine theta. So my stretch of my spring is equal to my spring constant times the stretch, which is L minus 3, which is 3 over cosine theta minus 3. So that gives me two equations and two unknowns. And the two unknowns are Fs and theta. In a separate video, I'll show you in an Excel file that solves this system. You can enter this in the nSpire in the way I just showed you in the previous problem. If you let f equal x and theta equal y, then you can plug those equations in on the solve function. And the best, you get multiple solutions, but the best answer is Fs is about 190 newtons, and theta is about 27.4 degrees. I'll show you how to do that in Excel, but you get basically the same answer. There's actually one more way to solve this system, is you actually have these two equations, and you can sub one into the other and do some algebraic simplification, and you basically end up with a single equation in theta. Now it's nonlinear, it has to iterate for it, and so you can actually go to solve, and that's another interesting function in nSpire. So if you ever need to solve a nonlinear equation, you can just use solve. And so you can just go to catalog, S, solve, enter. And we're going to go tangent of theta, trig, tangent of x, I'll just use x for theta, x minus trig sine x, x minus 0.05823, 0.05833 is equal to 0. and then we'll go comma, and we're solving for x. So we just entered this equation right here, and we go enter. And it gives us several choices for x, but the correct one is 27.43. 27.427 degrees. And then Fs, just take one of these equations and solve for Fs is 190 newtons. So, not easy, but you're defining the system using the equations and getting that result.